Hello, class. This is the lesson on Chapter 9-9A, Similar Solids. Similar solids are two solids that have the same shape, and all the corresponding lengths are proportional. For example, we could have two similar pyramids, as pictured here, or we could have two similar cylinders, or we could have two similar prisms. The first thing we're going to do is work at finding dimensions of similar solids. This is going to remind you very much of finding the dimensions of similar polygons, which we did earlier this year. They're telling you in this particular example that the two pyramids are similar. Therefore, we know that the lengths of the sides have to be proportional. What they want us to do is find the value of x. Now, if you'll note, they have given you the slanted height of both of the pyramids, and they have given you the length of the base rectangle. The first thing we're going to do is write a proportion, and then we are going to use cross products to solve. Now, when we're going to write the proportion, we have to make a decision how we're going to set it up. You could go with the left-hand pyramid over the right-hand pyramid, or you could go the right hand over the left hand. You could also go with the small one compared to the large one, or the large one compared to the small one. It really doesn't matter. It's just important that you individually stay consistent. And I stay consistent by taking the left one over the right one, or the top one over a bottom one if they show it to me as a top and a bottom picture. Sometimes they will give you an A. They'll have like a capital A on the first one and a capital B on the second one. Then I will go A to B. In this particular instance, I am going to go with left over right. The first thing that I guess hits me is the 5 to 12. Those are corresponding lengths that I'm originally given. Now, because the 5 came from the left-hand pyramid, I'm going to put the 6 in the top position as well. Remember, if it's left over right on the left-hand side of the proportion, then it's got to be left picture over right picture on the right-hand side of the proportion, over x. Now, I look to see if I can reduce, and I cannot. 5/12 is already in lowest terms. So now I'm going to do that cross product. Now, it's been a while. Do you remember how to do that? You're going to take 5 times x equals, and then we're going to take 12 times 6, which is 72. Now you have a one-step multiplication equation, which I will solve by doing the inverse of dividing by 5. X is going to equal 14.4. I need a label of centimeters. At this time, you hit pause and you try example B. Okay, class, you've had an opportunity to try it. I'm just simply going to use diameter compared to diameter, left to right. 4 to 5 equals y over 11. Remember, if I've gone left to right over here, I have to go left to right over there. I'm going to take those dots out, because otherwise you might think they're decimal points. Now I'm going to go with my cross product of 5y equals 44. And I will divide both sides by 5. Y is going to equal 8.8 meters. There will be times when they are going to give you the problem written out. Yeah, it takes a little more work, okay? They're going to tell you that you have two triangular pyramids that are similar. In the triangle that form the basis, the height of the smaller one is 6 inches, and the height of the larger one is 9 inches. And the slant height of the larger one is 15 inches. You need to find the slanted height of the smaller. So what they're telling you, first of all, in that second sentence, is that you have a smaller height compared to a larger height. That's 6 to 9. Now you'll note that it's smaller over larger. I don't know the smaller height, slant height, but I do know the larger slant height. This is where you've got to be careful if you're going smaller to larger. You can do this without reducing, but I find that if I reduce, I can sometimes end up not having to use a calculator at all, so it saves me some time. I can take a 3 to reduce and get 2/3. 3n is going to equal 30 on my cross product. And it's pretty obvious here that you really don't need a calculator to solve this one to get 10 inches. That's the first part of what you're going to do. In the second part, we are going to find what's called the similarity ratio. And then in lesson 9.9b, we're going to find out how to use that similarity ratio to help us find the area of similar solids and the volume of similar solids. The similarity ratio simply refers to the ratio in lowest terms of the known corresponding lengths. Find the similarity ratio, reduce to lowest terms, and note that here is where they give you an example of one where it says compare A to B. Remember, I talked earlier in the lesson that sometimes they will put a letter by the prism or the pyramid. Here's the situation where they're doing it. They want you to compare A to B. Now, I have to find the corresponding parts. This 6 would correspond with this height over here. I don't know that height. This 7 would correspond to the length over here with B, and I don't know that. This 9 does correspond to 6. They are both the lengths. Now remember, it says A over B, so that means I have to compare 9 over 6. What I do is reduce this to lowest terms, and as I tell you in the note here, you can leave the ratio in the form of an improper fraction. That is perfectly okay. So I'm going to have 3 over 2. That is my ratio. There is no label for it. That's just it. 3 over 2. Here we have two cones, and again, they are telling you to compare A to B, and sure enough, they have them listed. Now, if we take a good look at the two cones, you can tell that we know the heights of both cones, 6.4 and 9.6. A to B, 6.4 over 9.6. Now, the reason I chose this example is a lot of times students will take a look at something that has a decimal like this and they'll go, oh, I don't know what to do with it. Well, here's how you handle it. They're both tenths. So a little tip, multiply them both by 10. You're going to get 64 over 96. Now you can reduce them. It's very easy to see, first of all, that there's an 8 in there. So there's 8 over 12. And now I can take out a 4, and I will get down to 2 over 3. Now, look back at the decimals. They're both in tenths. You must do the same thing to the decimals. So if this would have been 6.44 and 9.6, I would have had to multiply by 100. If it was 6.04 and 9.06, I would have multiplied by 100 and then reduced. Most of the time, you will see these with the same place values. They'll both be to the tenths. But that's how you actually handle those problems. You just multiply them by 10 so you get whole numbers. Then you write the reduced ratio. Okay, here's the last one. A to B. They've only given me the slant heights. 30 over 17. Now 30 is a composite number made up of 2 times 3 times 5, and 17 is a prime number. So this is already in lowest terms. And this is where it becomes very important to say, all right, I can leave them as improper fractions. And that concludes lesson 9-9A. Please respond with flute. That's F-L-U-T-E, flute. Catch you next time.